Question number 1. This is Physics Paper 1, 2022, revision. State what is meant by area. So this question is asking you to, in other terms, to define the term area. So the student is expected to give the exact meaning of what area is. So we usually define area as the measure of an extent. Measure of an extent of a surface. Measure of an extent of a surface, or measure of the space covered by a certain surface or a body. So measure of that space or measure of that extent, that is what we define as area. Number B, question 1, number B, state the SI units of area. So here you are asked about the SI unit, not just any units, because we have many units of measuring area. So we have, for example, we can measure area in centimeters squared, we can measure area in square millimeter, as well as square kilometers, but these are just subunits. So the main unit is square meter, which is abbreviated in symbols that way. So that is the SI unit of area. It is also good when you are writing the SI unit, you write it in words and also in symbol. Then from there we go to number 2. Number 2, explain why water in a glass tube forms a concave meniscus. Why water in a glass tube? For example, if this one is a glass tube, you are going to find that water will cling on the sides. It will cling on the sides of the tube and form a concave. So this one is now the concave meniscus. So the reason for this shape, there are forces which usually occur between the molecules of different substances. Like in the water, between water and the glass tube, we have in different molecules. So there is a force we call adhesion or adhesive force. There is also another force which occurs in between the molecules of water. That is in between similar molecule, we call it cohesive force. So the reason why this one clings on the sides, it is because the adhesive forces are much stronger than the cohesive force. So in your answering, the candidate should approach this question and use the key words of what I have discussed. So we usually say the adhesive forces between water molecules and the glass particles are much stronger than cohesive forces in water molecules. Hence, for that reason, they pull the water surface tension and make it clean and cling it on the sides, forming a concave meniscus. So in other terms, what we are calling meniscus, in this case, the term meniscus just means that curve, the curve that is usually formed by a liquid surface when it clings on the sides of a given tube or vessel. That is what we refer as meniscus. So from there, That answer will be sufficient to earn you 2 marks. Let's go to number 3. So in number 3, the figure below shows how water is drawn from a large tank into a low-lying container using a rubber tube. So you can see we have one container on, at the upper hand, the other container is below. So this is working over siphon. So in working over siphon, you have to consider which side is the mouth and which side is the end of the tube. Like you can see here, this side, we can call it side A, and this one side B. So as long as side B is below side A, the water will be able to flow under gravity. But now it does not just flow automatically. You have to do a certain procedure so that the water can be able to come out. So the first thing, you insert the tube in the water. Already it is inserted. So after that, there are 2 ways in which you can be able to make this water flow and come out of the tube to the lower vessel here. So the first thing, you suck the air that is through the tube. When you suck the air through the tube, what will happen? The pressure inside the tube will decrease. When that pressure decreases, what will happen? On this side of this tank, we have the atmospheric pressure. So you say the air atmospheric pressure on the surface of the tank on higher level will push the water past the through the tube and ensure continuous flow. So that is how you approach that question. The reason why after sucking the air through the tube we have in the pressure decrease, it is because there is going to be a virtual vacuum will be created inside the tube, and that one will make the water to continue flowing under gravity. Number 2, method 2, you evacuate all the air through the tube, then you fill the tube with water. After filling the tube with water, you insert it on the upper tank and then release this end B. And as that water comes out, it is going to form a continuous flow because atmospheric pressure here will be already acting on the surface of this liquid, pushing it past the tube, and then water will flow in that direction to that tank. That is method 2. So that is working of the siphon. That is application of pressure in liquids, form 1. So let's go to the next question. The next question is asking, number 4, state how a piece of paper can be used to demonstrate that matter is made of tiny particles. So this question is asking you to state. So the first thing you should be able to state, for example, so you say if you cut, so you cut the piece, you cut the paper into smaller or tiny particles. After you cut the paper into tiny particles, you will not be able to rejoin the particles again, and that is to mean you will have as many pieces of paper as possible from the main paper that you have already cut. So that is to show that matter is made up of very tiny particles. We had one state of the matter, which was the paper. Then after cutting, you have very many pieces. You can also demonstrate that. Like for example, this one is the paper. So in step 2, you cut the paper into different pieces. So here, like you can see, we have 2 pieces. You continue cutting. You are going to have smaller pieces at the end. And these tiny particles of paper, they show that matter has got tiny particles. So this one are the tiny particles of paper we are talking about. So from there, next is the working of a thermometer. This is the 6 maximum and minimum thermometer. We are asked to show how it works. So as you can see from the diagram, we have inside P and Q, we have alcohol at the top, and then we have in metal index here B and A, then we have mercury. So the question is, explain how increase in temperature causes index A to move upward. So we are interested with the index A. So what will happen? An increase in temperature here. Remember, here we don't have a partial vacuum, but here we have a vacuum. We have a vacuum. So in case of expansion, we are going to have the liquid taking this route and moving up, because we are interested with why this one is going to go up. So in this case, increase in temperature will cause the alcohol and mercury to expand. So that increase in temperature will cause alcohol here and mercury to absorb its energy and expand. During expansion, the metal index A will be pushed upward, so that the alcohol on upper arm of Q occupy the vacuum or the space above it. And that for that reason, you are going to find that metal A, index A, will move up because of that expansion. So that is question on thermometers, also from Form 1. Then the next question is asking us to differentiate between heat and temperature. So as we know that heat is a form of energy that it is a form of energy that flows due to difference in temperature. While, so because you are differentiating, you should use that term while to show the difference. Temperature is the degree of hotness or coldness of a body or place. So we have either body or place. So the key word here for the heat, we should see the term energy, because that is what defines heat. If a student say heat is a form of energy, while temperature is the degree of hotness or coldness of a body or place, they will also be correct. So that is the definition on the difference between heat and temperature. Also, you can differentiate heat and temperature in terms of SI unit. So we know the SI unit of heat is joules, which is abbreviated as capital J. We know the SI unit for the temperature is Kelvin, which is abbreviated as capital K. So you can also differentiate heat and temperature in terms of their SI unit. You can also differentiate them in terms of measurement or the instrument used to measure the two. But now the main difference will come from their own definition, because the definition covers almost every concept from there. So far so good. We are now in question number 7. Question number 7.